Hyundai are the world's first manufacturer to take a fuel cell electric vehicle into mass production. In this film, as global leaders in this new and exciting technology, we want to answer some of the fundamental questions about hydrogen and why we believe it is the fuel for today and the future. So what is hydrogen and where does it come from?
Hydrogen is the most common element you can find anywhere in the universe. It's in the trees, it's in the water, it's in the human being.
In fact, 75% of the universe mass is based on hydrogen.
With hydrogen being the most abundant chemical element in the universe, there is a plentiful supply. So how is hydrogen converted or farmed to enable it to be used in a fuel cell?
As of today, most of the hydrogen is produced from fossil feedstocks, such as natural gas through steam methane reforming.
Steam methane reforming in natural gas works when steam of up to 1,000 degrees Celsius reacts at pressure with the methane to produce predominantly hydrogen. Hydrogen fuel produced this way creates up to 30% less CO2 emissions than using traditional fossil fuels and is already happening on a large scale.
In the long run, hydrogen will be produced from renewable sources, such as wind power, biomass, for example.
북유럽 같은 경우에는 그 풍력이나 그다음에 태양광을 이용하여 남는 잉여 전력을 수소를 만드는 데 사용하고 있습니다. 그리고 이 수소는 곧 운송인 연료전지 차량으로 다시 환원돼서 이용할 수 있고 그 환원된 에너지를 이용하여 생성된 물은 또다시 수소를 만들 수 있는 그런 원동력이 되는 것입니다.
As more fuel cell electric vehicles are produced and the demand for hydrogen increases, so commercial production will continue to expand. With a hydrogen fuel cell vehicle taking just 2 to 3 minutes to fill, this will lead to the refueling infrastructure across Europe rapidly improving.
So if you take a look at Germany, for example, currently there are only 15 public hydrogen fueling stations. The challenge is to scale this up. The aim is to have by 2015 50 fueling stations, and these 50 fueling stations are strategically located in a way that people will be able for the very first time to travel with a fuel cell car throughout the country.
Countries such as Norway and Denmark are also emulating this approach. And it is predicted that by 2020 there will be over 400 refueling stations all across Europe. As the infrastructure continues to expand and carbon-free hydrogen production grows, our aim at Hyundai is that one day we will all benefit from fuel cell technology, delivering personal mobility with zero compromises and zero emissions. Hyundai are the world's first manufacturer to take a fuel cell electric vehicle into mass production. The development of Hyundai's hydrogen fuel cell technology has been ongoing for the past 15 years and is changing the way we will all approach personal mobility in the future. In this film, we are going to describe how a fuel cell actually works. Put simply, a hydrogen fuel cell is a device that converts hydrogen into electricity. Hydrogen is one of the simplest elements in the universe, consisting of one proton and one electron. On Earth, it occurs as H2, 2 atoms of hydrogen joined to form one molecule. For the fuel cell to work, it needs 2 feeds, hydrogen and oxygen, which have an electrochemical reaction with the only byproduct being water vapor. So how does a fuel cell generate power? There are 3 main components in a fuel cell. The first is the proton exchange membrane, or PEM, that lets protons pass through but not electrons. Then we have the anode and cathode, which allow electrons to flow in and out of the fuel cell. To start the reaction, hydrogen is directed into the anode, where, as mentioned, the proton and electron split, with the electrons travelling up the anode, while the protons pass through the PEM. The flow of electrons from the anode to the cathode creates an electrical current and power. In the cathode, the electrons are reunited with the protons and mixed with oxygen from the air. This reaction creates just heat and water vapour, meaning the only emission is H2O. Multiple fuel cells are combined into a fuel cell stack to magnify this reaction, producing more energy for greater power and longer range. Electricity generated from the fuel cell stack is first transmitted to the inverter and then to the motor, propelling the vehicle.
The resources in the future will come down. We have to think about alternative technologies like the fuel cell.
I'm sure that hydrogen vehicles will become a part of the propulsion concepts in future.
What is brilliant with fuel cell is you using this pure hydrogen, producing electricity in your car for your mobility, and at the end you get water. There is no more sustainable mobility than this one. It is enabling at any time CO2-free mobility.
We have spent 15 years developing hydrogen fuel cell technology to establish ourselves as an industry leader in the field of eco-technology. The iX35 is the first step in helping reduce carbon emissions, an undertaking that will continue as we strive to play a major role in moving the world to an environmentally sustainable future. At Hyundai, our philosophy of new thinking, new possibilities is exemplified by our work in developing a technology that allows our iX35 fuel cell electric vehicle to run on hydrogen and emit nothing but water vapour. New thinking, new possibilities isn't a catchphrase simply developed by the people in marketing. It's a commitment that has seen Hyundai invest tens of billions of euros over the past 15 years in fuel cell technology alone. We are the first company in the world to mass produce fuel cell electric vehicles.
This iX35 fuel cell is the result of 15 years of research and engineering. It's the first step in the new era.
It's a journey that started in 1998 with the establishment of a fuel cell research unit. 2 years later, in 2000, we launched our first FCEV prototype using the Santa Fe. This had a modest range of 141 kilometers and a fuel cell power output of 65 kilowatts.
(2000년도에) 산타페 연료전지로서는 그 당시 기술력으로는 하이브리드 기술력이 아닌 연료전지 단일 차량으로서의 기술력으로서 150km에서 200km 정도의 주행거리를 확보할 수 있었습니다. 그러나 현재 저희 현대 연료전지 자동차는 하이브리드 개념을 적용하여 최대 600km 정도가 주행 가능한 기술력을 이루었습니다.
The following decade saw a continual improvement in performance and power as Hyundai engineers continued to refine and test our technology. In 2010, we reached a landmark, clocking up a total distance of 2 million kilometers in testing, the equivalent of driving an FCEV vehicle 50 times around the equator.
We tested the fuel cell vehicle under different European weather conditions.
In the winter, we have to take care that it's not get frozen. That we have tested in our climate chamber down to minus 25 degrees. So that means we are doing there outside on the highway in the city to convince and consider all driving conditions during the usage at the customer.
Today, Hyundai's production line FCEV has 100 kilowatts of power, a range of 600 kilometers, acceleration of 0 to 100 kilometers per hour in 12.5 seconds, and a top speed of 160 kilometers per hour. But it's not only the performance of our vehicles, safety is also of paramount importance.
We have simulated and conduct severe crash tests with our hydrogen tank.
And our focus was rear crash, because there are the tanks located and even the battery. So we did the tests 2 to 3 times more difficult and more challenging like you can normally expect within your car. We're fulfilling all worldwide standards that you can feel really safe.
The fuel cell vehicle is as safe as any other car on the road today.
During the last decade, other green vehicle systems have also been developed. These include hybrids and a fully electric vehicle. So how does FCEV compare to these other technologies?
In a fuel cell vehicle, there are no moving parts, no piston moving away, which is producing much less noise.
The recharging will be in a similar time duration like your standard car.
You can refill your vehicle in a few minutes. You don't have to wait overnight.
But it means you have not to adapt yourself driving a hydrogen vehicle that much compared to electrical car.
You can drive it like a normal vehicle. It's just more silent than a normal car and has a feel of lightness.
Today we have the world's first production line FCEV vehicle, the iX35. As the network of hydrogen filling stations continues to rise across Europe, so increasingly motorists will have a far greater choice on the type of technology they opt for.
I'm confident that hydrogen vehicles will be part of the system or the cars in future. I hope that also the noise pollution in cities will reduce dramatically.
Our responsibilities is to build up cars to save the environment for the future.
Yeah, this would help for a better place to live.